welcome for today's lesson. We wish to continue with what we have been covering from our previous lesson. In this particular lesson, we are going to look at the midpoint and length of a line segment from diagrams. So first of all, before we establish the method we can use to calculate the midpoint and the length of a line segment, it will be important for us, first of all, to understand the meaning of the word midpoint of a point. So midpoint, abbreviated as M, in this case we shall be using M, is defined as a line segment, is a line segment is halfway point between the two endpoints. So that means if we have a straight line with the two endpoints, suppose we call them A and B, then the midpoint of that line segment A and B can be obtained. Now, before we establish a method, let us represent on a Cartesian plane 2 points, A, whose coordinates are 1 and 5, and point B, whose coordinates are 4 and 2, and determine the midpoint without using calculation method. Now, from the diagram that we have drawn, we have a line segment AB. From that line segment, we can be able to identify the midpoint without necessarily calculating, but by just inspection. So in that case, we establish that the midpoint is identified as point M, whose coordinates will be X, Y, where X represents the X coordinate for the midpoint and Y represents the Y coordinate for the midpoint. So by inspection, the point will be, for the X will be 2.5, then for the Y will be 3.5. That is by inspection from the diagram. But now, instead of using the diagram or plotting the 2 points on the Cartesian plane, we can identify or establish a method which is suitable for calculating the midpoint of two endpoints of a line segment. So for this case, we need to establish how we can get this 2.5 as the X coordinate for the midpoint using the coordinate, X coordinate of point A and the X coordinate for point B. Now, to find the midpoint, because it's a halfway point between the two endpoints A and B, what we can do, we first of all find the X coordinate for the midpoint. to get the x-coordinate for the midpoint, we can take the first x-coordinate, x1, which is 1, plus the second x-coordinate, which is 4, then you divide by 2. So in short, we get the average of the x-coordinates of the end points. So the result will be 5 divided by 2, which is equivalent to 2.5. So that means the x-coordinate for the midpoint will be 2.5. What about the y-coordinate? For the y-coordinate of the midpoint, we shall again get the average of the y-coordinates for the endpoints. In this case, we shall take y1, which is 5, plus y2, which is 2, divided by 2, (7 divided by 2 is 3.5. That implies that the y-coordinate for our midpoint is 3.5, which coincides with the inspection method. So in general, we can say the midpoint will be the midpoint will be 2.5, 3.5. Let us now come up with a method which we can apply to calculate midpoint using a general way. For example, point A, the x-coordinate, we let it to be x1, while the y-coordinate is y1. For point B, we let the x-coordinate to be x2 and the y-coordinate to be y2. How do we find the midpoint using the general case? In general, to determine the midpoint of a point A, x1, y1, and a point B, x2, y2, those are the endpoints of that line segment. And the midpoint M is x, y. To determine that, we just take the average of the x-coordinates of the endpoint, that is x1 plus x2 divided by 2, then the y-coordinate will be y1 plus y2 divided by 2. So that is how we get the midpoint of any given point in general. Now, to find the midpoint of a line segment using the method of calculation without necessarily drawing that particular line segment on the graph, we apply the formula midpoint x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. For example, Now, in this particular example, we wish to find the midpoint M, x, y of the line segment joining these pairs of points. So in the first part A, we have point A, which is 1, 0, and point B, which is 4, 4. Then in part B, we have a point C, which is negative 3, negative 2, and a point D, which is 5, 3. How do we find the midpoint? So solution. To find the midpoint, we represent by letter M, which will be given by, we take x1 for part A, x1 is 1 plus x2 is 4 divided by 2. That is the average of the x coordinates of the endpoints. 5 divided by 2, and the result is 2.5. That is the x coordinate. Then we need to get the y coordinate. We need to get the y coordinate. We shall take y1, which is 0, plus y2, which is 4, divided by 2. And 4 divided by 2 is 2. So that means the y coordinate for that midpoint is 2, while the x coordinate for the midpoint is 2.5. We now combine. So combining the two coordinates, the midpoint becomes 2.5, 2. For part B of that particular question, we have the first point as negative 3, negative 2, and the second point as 5, 3. So what we do, we assign the coordinates. So for the first point, negative 3 is x1, then negative 2 is y1. For the point D, the first coordinate is x2, and the second one is y2. Then we write down the formula or the method for finding midpoint. We take x1 plus x2 divided by 2. Then y1 plus y2 divided by 2. Once we have written down the formula for getting midpoint, we now do the substitution. Where there is x1, we substitute -3, and where there is x2, we substitute -2. Similarly, where there is y1, we substitute with the -2, and where there is y2, we substitute with the +3. So x1 is -3, x2 is 5, y1 is -1, y2 is 3, -3 plus 5 is -2, is +2, then -2 plus 3 is +1, and therefore the midpoint is 1, a half, which can as well be written as 1, 0.5. So that is basically how we get the midpoint for part B. Suppose we sketch these 2 points on a Cartesian plane. Let us see how we can locate that midpoint. So going back to our Cartesian plane, point C is -3, -2. So the point C is -3, -2. Then point D is 5, 3. If we join the 2 points, we obtained a straight line. So in that straight line, you will find that the midpoint of that line will be here, where the x-coordinate is 1 and the y-coordinate is a half. So you realize that the graphing part corresponds with when we apply the formula method. So all along we shall be applying this method of computing midpoint by just getting the average of x coordinates of the endpoints and the average of the y coordinates of the endpoints without necessarily sketching the graph or drawing a graph or the line segment on the Cartesian plane. Let us now proceed and look at the second part, that is finding the length of a line segment. So when you talk about the line segment here, length of a line segment, we are implying the distance between two endpoints. So it is simply, the length of a line segment is simply the distance or interval between two endpoints of the line segment. Let us consider 2 points . Let us consider the 2 point -1, 2, and another one is 4, -1, and see how we can determine the line segment, the distance between the 2 points. So to start with, let us try to plot the 2 points and identify the horizontal and vertical distances. So point A is negative 1, 2. It has been plotted using that dot. Then point B is 4, comma, negative 1. We now join the 2 points using a straight line. Now, how do you get the length from point A to point B? You notice that to get this length A to B, we can be able to introduce a right angle triangle So the right angle triangle has been introduced. So this is the extracted right angle triangle where this is point A and this point B. That's our line segment. So we need to get the units from A to where we have our right angle. So if we count, literally, you find that the units are 1, 2, 3. 3 units vertically. That represents vertical distance. We need also to calculate the units on the horizontal part, which will represent horizontal distance. We have 1, 2, 3, 4, 5. That is horizontal distance. So that means vertically we have 3 units, then horizontally we have 5 units. Since this is a right angle triangle, we can be able to get the distance AB, which is equivalent to hypotenuse. So the hypotenuse we can represent by letter C, while the horizontal distance we can represent by B. The vertical distance can be represented by A, and if we consider the right angle triangle, we can apply Pythagoras theorem to get the hypotenuse. Applying Pythagoras theorem, C squared, which is the hypotenuse squared, will be equal to A squared, which is one of the shorter sides, plus B squared, which is the base of that right angle. Our A in this case is 3 units. The B is 5 units. If we square, 3 squared is 9. 5 squared is 25. So we find that C squared is 34. And if you want to find C, which is the hypotenuse side, we are supposed to find the square root of 34, and we only take the positive square root because we are dealing with a length, and length is always positive. So if that is done well using a calculator, the result is 5.83. Units corrected to 2 decimal places. So length is always measured in units, where units can either be centimeters, millimeters, meters, kilometers, and so on. But because here it's not specific, we just give the answer as 5.83 units, corrected to 2 decimal places. Now that is how we can use the graph once you have plotted on the graph. But suppose you want just to do calculation without necessarily applying using the graph. How do we get the vertical distance and how do we get the horizontal distance? This is how we can get the vertical and horizontal distance without necessarily drawing the graph. So since point A is -1, 2, and point B is 4, -1, the first step is to identify the x-coordinate. In this case, we shall let the first x-coordinate for point A to be x1, then y-coordinate for point A to be y1, then x-coordinate for point B to be x1, x2, then the y-coordinate for point B to be y2. Once we have the two, we get the horizontal distance. The horizontal distance, let us call it x, is obtained by taking the upper value for x minus lower value for the endpoint. So horizontal distance is obtained by taking upper minus lower values of x coordinates of endpoints. So in this case, we shall pick the upper value for x coordinate will be x2 minus x1, which will be 4 minus which gives us 5, because 4 minus minus 1 is 4 plus 1, which is 5. Then vertical distance is obtained by taking the upper minus lower values of the y coordinates of the endpoints. Upper y minus lower y for the endpoints. In our case, the upper value for y is 2 minus the lower value for y is minus 1 that means 2 plus 1 is 3. So you'll notice that again the horizontal distance is 5, which is in line with what we had previously, and the vertical distance is 3, which is in line with what we had previously. Since this is representing a right angle triangle, we apply Pythagoras theorem. By saying c squared is equal to 5 squared minus 3 squared. Not minus, it's plus. So c squared is equal to 5 squared plus 3 squared. So c will be equivalent to square root of 34, which is 5.83. Units corrected to 2 decimal places. So that's what we shall be using to calculate without necessarily plotting on a Cartesian plane. Another example. Find the length of the interval So the question reads, find the length of the interval joining these pairs of points corrected to 2 decimal places. So in part A, the first point is 1, 2, and the second one is 3, 4. In part B, the first point is -1, 3, and the second one is 2, 1. So try the first one, part A. Now for part A, we can be able to indicate the coordinates here. 1 is x1, 2 is y1, then 3 is x2, and 4 is y2. So we start by getting the horizontal distance. Horizontal distance is obtained by taking the difference between the upper value of x and the lower value of x. Between 1 and 3, which one is the upper value of x? You will notice that the upper value of x is 3 minus the lower value, which is 1, and we have 2 units. Then we get the vertical distance. We shall take the upper value of y between 2 and 4. Which one is the upper value of y? You'll also notice that the upper value of y is 4 minus the lower value of y is 2. 4 minus 2 is equivalent to 2. That means we have a right angle triangle where the horizontal distance is 2 and the vertical distance is also 2. We need to get the hypotenuse, which is represented by C. And that is the length of that line segment. So you can say length will be 2 squared plus 2 squared which is equivalent to 8. And to get that length, let us use letter C for convenience at this point. C squared is equal to for convenience, we shall use C, will be A squared plus B squared. That is Pythagoras' theorem. C squared is equal to 2 squared plus 2 squared, and that is 4 plus 4, which leaves us with 8. Now to get the square root of C, to get C, we are supposed to take the positive square root of 8. So use your calculator to get the positive square root of 8 and correct your answer to 2 decimal places. Now the square root of 8 correct to 2 decimal places will be 2.83. So if you use your calculators very well, we expect you to get this answer 2.83. And because C is a length, we can conclude by saying therefore length between those 2 points is 2.83 units. And that is the value. Let us try part B of the same question, where the coordinates are -1, 3, and the second point is 2, 1. How do you get the distance between these 2 points without necessarily plotting? Again, we indicate this as x1, y1, x2, y2. Then get the horizontal distance. Horizontal distance is obtained by subtracting upper value of x minus lower value of x. So the upper value of x is 2 minus the lower value of x is 1. That leaves us with 1. So for vertical distance of our vertical distance will be obtained by taking the upper value of y, which is 3, minus the lower value of y, which is 1. And the result is 2. If we sketch our right-angled triangle, A, which is horizontal distance, is 1. Then B, which is the vertical distance, is 2. We can be able to get C, which is now the length between the 2 points. From our Pythagoras theorem, we know that c squared is equal to a squared plus b squared. A is 1, B is 2, so c squared is 5, implying that the value of c will be the positive square root of 5, which we can obtain using our calculator. So using your calculator, can you find the square root of 5? Correct it to 2 decimal places. So if you press your calculator very well, we expect you to get an answer of 2.24 corrected to 2 decimal places. And therefore, we can conclude by saying that the length between the point -1, 3 and 2, 1 is 2.24. Units. As I mentioned, the length is measured in units. So it will be 2.24 units. So we are now going to extend the knowledge of gradient to perpendicular lines and parallel lines. And in case 1, we shall start by discussing parallel lines. So to understand the gradient of parallel lines, what is the relationship between the gradient of parallel lines? We need to consider two equations of lines. So we consider two lines, y is equal to x plus 1, and another one, y is equal to x minus 2. So we have two lines here drawn on a Cartesian plane. Line 1 is y is equal to x plus 1. And line 2 is y is equal to x minus 1. From those two lines, we can be able to get gradient by comparing with the general equation y is equal to mx plus b. That means m1, that is gradient for the first line, is 2. Also, it implies that gradient for the second line is 2. Now, when the two lines have been plotted, they are parallel. So that means if two lines are parallel, then they have the same gradient. So the two symbols shows that the lines are parallel. So if the two lines are parallel, then they have the same gradient. So we can conclude by saying that parallel lines have the same gradient. Let us look at an illustration which will assist us solve questions involving parallel lines. So find the equation of a line which is parallel to y is equal to 3x minus 1 and passes through a point 0,4. That means the y-intercept is 4 in this case. Now to start with, we need to understand that if lines are parallel, then they have the same gradient. That means M1 is equal to M2 for parallel lines. And therefore, we need to find the gradient of this first line, L1, by comparing its equation with the general equation y is equal to mx plus b. For line 1, the equation is y is equal to 3x minus 1, implying that m1 is 3. So the gradient of that line is 3. Now, we have another line which is parallel to this and is passing through a point 0,4. So, the gradient M1 is 3. It means M2 is also 3 because they have the same, they are parallel. And therefore, we can be able to get the equation of the second line. In the form y is equal to mx plus b, where m is the gradient and b is the intercept. But m is 3 and y-intercept is 4 because the point is 0,4. So it means that line is cutting the y-axis at 4. So the final equation becomes y is equal to 3x plus 4. That is the equation of that parallel line. Now, basically, that's how we relate the gradient of parallel lines. That marks the end of our today's lesson. When we meet next time, we shall now look at relationship between the gradient of perpendicular lines. Enjoy the rest of the day. Thank you.